Welcome back, class. In part 3 we are discussing chapter number 8, which is switching. Earlier in part 2 we discussed about the basics of circuit switching with some examples. This lecture will be all about circuit switching. It's about now let's talk about the three phases. The actual communication circuit switch networks requires three phases: connection setup, data transfer phase, and the connection teardown, which is called teardown phase. Let's talk about the first phase, which is the setup phase. Here, first phase. Before the two parties, this is like station A wants to communicate with station M, can communicate. These two parties, before they can communicate, a dedicated circuit, this circuit need to be established from here to here. Okay. The end systems are normally connected through dedicated lines to a switch. So the station is connected with the switch. This station is connected with the switch, meaning they are part of the network. So connection setup phase means creating dedicated channel. So we will dedicate a channel between switches, this one and this one. That means 1, 4 and 3. We will dedicate a channel between the switches. When system A needs to connect to system M, it sends a setup request that includes the address of system M. It should have an address to switch number 1. Switch number 1 finds a channel between itself and the switch number 4 that can dedicate for this purpose. So a channel need to be dedicated for this purpose. Switch 1 then sends a request to switch 4, which sends a dedicated channel between itself and switch number 3. So channel 4 will find a dedicated channel between itself and switch number 3. Switch 3 informs system M of A's intentions, whether that the Mr. A, station A, wants to communicate with you. In the next step of making connection, an acknowledgement from system M needs to be sent in the opposite direction to system A. So Mr. M will send us acknowledgement all the way using the same link to Mr. A or station A. Only after system A receives this acknowledgement is the connection established. It can communicate. Note that end-to-end address is required for creating a channel connection between the two end systems. This can be, for example, the address of the computer assigned by the administrator in a TDM network, or telephone number in a FDM network. So it can either be FDM if we are communicating between computers or system to system, or if we are using a telephony network, then it has to be a FDM network. Now let's talk about data transfer. After the establishment of dedicated circuit, the two parties can transfer the data in the form of signals if you are talking about the FDM or TDM. Once they finish the communication, one of the parties need to disconnect. Either this one disconnect or this one disconnect. A signal is sent to each switch to release the resources. So this switch will release the resources, this switch will release the resources, and eventually this switch will release the resources so that others can communicate. In next slide, we'll talk about the efficiency of this network, how much efficient this network is, and we'll talk about delay. This is basically a picture of delay. Let's talk about first the efficiency. It can be argued that circuit switch networks are not as efficient as the other two types of networks, which is packet switch and message switch, because resources are allocated during the entire duration of the connection. So what we are doing is like we are using a dedicated link which can either be utilized or not to be utilized. It depends. The resources are unavailable to other connections when they are connected. Any other connection cannot be made between the two. In a telephone network, people normally terminate their communication when they have finished their conversation. However, in computer networks, a computer can be connected to another computer even if there is no activity for a longer time. In this case, allowing resources to be dedicated means the other connections are deprived. So the other connections can be made when this line is dedicated or being connected between the two stations. Let's talk about the delay. Although circuit switch normally has low efficiency, we'll talk about efficiency later. The delay in this type of network is minimal. The delay is minimal once the connection is developed or connected with the B. There is minimum delay of data transfer. During data transfer, the data are not delayed at each switch. The resources are allocated for the duration of the connection. So the resources are allocated, the lines are being connected. It's just like a button which has been turned on. The figure shows the idea of delay in circuit switch networks when only two switches are involved. So this is called the setup phase. This is the acknowledgement from the B. Then once the connection has been confirmed, data is transferred. Once the data, whatever, if you are talking about phone or two systems on our network, computer systems, once the data has been transferred, we send a disconnection request, and all the resources are disconnected in between the switches as well and the end stations. So this figure shows that there is no waiting time at each switch. The total delay is due to the time needed to create the connection. So this is a delay which is basically creating the connection. Data transfer and disconnect the circuit. The delay caused by setup is the sum of the four parts: the propagation time of the source computer request, the request signal transfer time, the propagation time of the acknowledgement from the destination computer, and the signal transfer time to the acknowledgement. The delay due to data transfer is the sum of the two parts, the propagation time and data transfer time, which can be very long. The third box shows the time needed to tear down the circuit. We have shown the case in which the receiver requests disconnection, which creates a maximum delay. So next time we'll be talking about packet switching. So see you on the next lecture.